Let's look at OpenStax College Physics, Chapter 3, Problem 58. A jet airplane flying from Darwin, Australia, has an airspeed of 260 meters per second in a direction 5 degrees south of west. It is in the jet stream, which is blowing at 35 meters per second in a direction 15 degrees south of east. What is the velocity of the airplane relative to the Earth? And B, discuss whether your answer is consistent with your expectations for the effect of the wind on the plane's path. So first, I want to write down my knowns and unknowns and draw a diagram. So the things that we know is that the plane has an airspeed of 260 meters per second in a direction of 5 degrees south of west. So what that means is that the plane, velocity of the plane relative to the air is 260 meters per second, and it has a direction of 5 degrees south of west. I'll know that better once I draw the diagram. I know what that means. All right, then we know that the jet stream, so the air, is blowing at 35 meters per second in a direction 15 degrees south of east. So we have the velocity of the air relative to the ground. That is 35 meters per second in a direction of 15 degrees south of east. And we're looking for, in part A, we are looking for the velocity of the plane relative to the Earth. I call that relative to the ground. So we want velocity of the plane relative to the ground. And in part B, we want to discuss this. So I'll just write discuss. All right. So I'm going to start by drawing my diagram. So here I have the coordinate system. So I have north up here, south, east, and west. And I know that the plane is flying in a direction of 5 degrees south of west. So south of west would be going west and then south of it. So that means that the velocity of the plane is going to be in this direction. So that would be something like that. And I know that that's much bigger than 5 degrees, but I want to be able to see it clearly. So this is the velocity of the plane relative to the air. Then we know that the wind blows 15 degrees south of east. So I have to look at east and then go 15 degrees south of that. So the velocity is going to be in this direction. And it's less than the speed of the plane. It's only 35 meters per second, so I'm going to draw it smaller. And this is the velocity of the air relative to the ground. And this is 15 degrees. So I have my drawing. Now I have to remember how to add relative velocities. And my equation was V of A relative to B is equal to V of A relative to C plus V of C relative to B. So this is the equation that I want to use. And just to remind you, I have to start with a subscript, and that has to be also the first subscript in the sum. The second subscript has to be the last subscript in the sum, and then the third one will drop out. So since I'm looking for the velocity of the plane relative to the ground, I'm going to start with the subscript P and insert the third subscript that we have here. So the third subscript is A. I want to start with P and with G, so the third one is the A, plus velocity of A with respect to G. So let's look at our values here, our vectors. So I want to add to this velocity that velocity to end up with my unknown. So this is fine. I have these both set up okay, except to add vectors, remember that you have to add tip to tail. These two vectors are added tail to tail. Both of their tails meet over here. So to add tip to tail, I have to bring this vector from here to the tip of that vector. So I'm going to redraw this. So here's my coordinate system. Here's my north, south, east, and west. There's my velocity plane relative to the air. And then this is the velocity of the air relative to the ground. So that would be the sum of these two vectors. That is velocity of the plane relative to the ground. So that's what I'm looking for. Now, none of these angles are 90-degree angles. So I will have to break all of my components, all of my vectors into components, x and y components, and work with that. So I will add some more labels in here. So I have this is 5 degrees. I know that this is 15 degrees. I'm crowding my picture. So what I ultimately want is when I project this vector onto the y-axis, onto my north-south axis, this will be VPGY. And when I project it to the x-axis, this will be my VPGX. Now, how do I get those components? If I project both VPA onto the y-axis and VAG onto the y-axis, I notice that the y component of VPA added to the y component of VAG gives me the y component of VPGY. So it gives me the y component of VPG is what I meant. Now, if I project them onto the x-axis, then projecting this onto the x-axis gives me this as my VPA y x, sorry, and then gives me that as my VAGX. So now I notice that I have VPA x going west and I have VAGX going east. So to find VPGX, I would have to subtract the VAG minus VPA to obtain this component of the velocity vector. So let's get to work. I'm going to work in the y direction first for no apparent reason. So I have VPGY is VPA y plus VAGY, and those are VPA sine 5 degrees and VAG sine 15 degrees. So when I plug in the numbers, I'm not going to take up room with that now. I end up with 31.7 meters per second in a direction south. Then if I work in the x direction, then VPGX is going to be VPAX minus VAGX. So that is VPA cosine 5 degrees minus VAG cosine 15. And when I plug in the numbers, I end up with 225 meters per second in a direction west. So now I want the entire vector. I don't want just the x and y components. So I will do VPG is square root of VPGX squared plus VPGY squared, And when I plug in the numbers, I end up with 227 meters per second. And now I'm looking for the angle as well. And if I want the angle with respect to the x-axis, so let's see what color I can make that. I don't have another unique color. I'll just use green here. So if I want this angle, then I'll say that inverse tangent of this angle is opposite. So that would be the opposite. This is the opposite, divided by adjacent. And I can get my angle that way. So I'll put it up here. Theta is inverse tangent of VPGY divided by VPGX. And when we plug in the numbers, we end up with 8 degrees. So those 8 degrees, as I drew here the angle, are with respect to direction west. So it is south of west. So the angle, my final angle, is 8 degrees south of west. So as a discussion, it turns out that while the plane is traveling at 260 meters per second relative to the air, it actually has a speed of 227 meters per second, a slower speed, and it's more towards the south than its original speed with respect to the air. So it's 8 degrees south of west rather than the 5 degrees south of west.